Without further ado, I would like to introduce our first speaker of today. It's Mr. Dmitry Tsivilev from Russia. He's the Deputy Director for Business Development at Rosatom in Western Europe. He's going to talk about the activities that Rosatom has got going and planned around applications for nuclear beyond electricity. And I know that he also has some interesting insights of how we can use nuclear technologies even for non-energy applications. So please, Dmitry, the floor is yours.
Thank you, Marcus. Good morning, everyone. I hope you're having a nice day. It is my pleasure to be invited to speak at this event. Without further ado, I will share my screen. As Marcus said, my name is Dmitry Tsivilev. I'm Deputy Director of Business Development in Rosatom Western Europe. It's Rosatom Regional Center in Paris. And we are covering both Western Europe and North America. First of all, I would like to say a couple words about Rosatom as a whole entity. We have been working in the nuclear industry for more than 75 years. Basically, we cover all spectrum of nuclear activities in Russia and abroad. We have quite substantial financial results demonstrating that we work quite effectively with our 10-year portfolio of overseas orders, accounting for around $140 billion. And speaking about our activities itself, we work with everything that is nuclear. We cover all aspects of nuclear power production, from uranium mining to power production and nuclear fuel cycle backend. And of course, we cover a number of activities in non-energy applications of nuclear energy. This includes nuclear medicine, gamma radiation, construction and operation of research reactors, applied and fundamental science, isotope production, and a lot of what we sometimes call byproducts of our main business, new products which evolve from our main competencies. Lately, this includes around 80 various products, which can be separated mainly can be separated in 6 groups. It's green energy. We are currently developing wind farms in Russia. We are working on hydrogen production and different ways of transport and utilize hydrogen. Of course, we are developing energy storage solution based on our production facilities. And we have distinct branch of business for nuclear medicine. It's Rosatom Healthcare, which covers both nuclear medicine itself and isotope supply worldwide, and irradiation centers. Of course, we have a lot of other non-nuclear businesses because as Rosatom is not only operator or is not only company providing nuclear fuel cycle solutions, we have a lot of borderline competencies. So from our experience with transporting nuclear materials and equipment for nuclear power plants, we have gained quite a lot of experience with logistics, which we are currently combining with our icebreaker fleet And speaking of icebreakers, Rosatom pays great attention to the development of Arctic region. We are the only company, and Russia is the only country operating nuclear icebreaker fleet. I will tell about it a few slides later. And our nuclear competence during the whole history of Russian nuclear industry required development of new and most effective materials to be used in nuclear sector, in nuclear power plants, in research reactors. So it allowed us to gain basis for development of composite materials business within Rosatom structure, special steels, rare and mining of and supply of rare earth metals. And of course, nuclear sector being high-tech sector, it couldn't work without steady and trustworthy digital solutions. So in course of operation of all our facilities and development of the infrastructure, we have gained quite a number of competences related to management of facilities, which now are being transformed to smart city solution, and directly software solutions for different stages of project management, from design to planned facility management. As I mentioned, we have great experience in the field of research reactors. We have constructed more than 120 research reactors worldwide. And we have 75 years of technological experience in this field. Currently, in Russia, there are 54 research reactors in operation. And currently we are using this experience to propose globally more complex solution based around research reactors. It's Center for Nuclear Science and Technology. It's like Lego modular product. So customer could choose research reactor of needed capacity and parameters, and add different elements like irradiation center, needed set of labs, radiation material science complex, nuclear medicine center with cyclotrons, etc. So basically, tailor-made, it could become a tailor-made solution for the needs of any customer. And we are currently developing such center in Bolivia, starting 2017. It's already in quite advanced stage, and we hope that in the nearest coming years, Bolivia will join our large nuclear family through its Center for Nuclear Science and Technology being developed and constructed by Rosatom. And as I mentioned, one of our main focuses is nuclear medicine. We have been working in this field for a long time. Rosatom has entities which produce isotopes. We use our reactor base, both research reactors and our power reactors, to ensure steady supply of isotopes worldwide. And of course, several of our institutes are involved in production of medical equipment. We have quite a good experience in production and development of cyclotrons and irradiation equipment. So we have quite extensive production base for supply of medical isotopes. We have wide client base. We supply our solutions to more than 50 countries. This includes both raw materials like molybdenum, generators, precursors, sources, isotopes for palliative care, and our supplies help around 2.5 million patients a year. And through many years, we have developed quite reliable supply chain, which is being managed by Isotope JC subsidiary of Rosatom, which is one-stop shop for our customers to get to cover their needs in any type of isotopes. And I think one of currently well-known and broadly heard of byproducts of our nuclear solutions is hydrogen. As everything in Rosatom, our hydrogen expectations and competence grow out from our nuclear experience. Especially when we are speaking about our potential West hydrogen cluster, which we are looking to develop around Kola and PP. We are looking forward to establish hydrogen production for potential export to Europe. And of course, we are looking to do it in partnership with our European counterparts. Maybe one most well-known case of our work in hydrogen is hydrogen cluster, which is currently being developed in Sakhalin region. It should cover a lot of aspects localized in one region, from hydrogen production itself to hydrogen transportation and to its export. We have great support from local authorities who see that it can be a very important and effective driver for the development of the region. We work closely together with our partners, including European one like Air Liquide from France. We work closely with local industry because there is a great need for decarbonization in Sakhalin region. So in a couple of years, we believe that it would become a great example of decarbonization of the region using hydrogen technologies, which are being developed and introduced there in a broad partnership of Rosatom and a group of companies, which each of them are working in its special area of this cluster. Speaking of Western hydrogen cluster, as I already said, it is going to be developed around our Kola NPP, which has some free capacity because it produces a bit more power than needed in Murmansk region. And considering that it is located in western parts of Russia, close to Europe, and also close to our northern transit corridor. It's a sea route which is being provided by Rosatom icebreaker fleet for year-round navigation. So there is a good potential for further export of hydrogen from this plant to Europe. And we are really looking forward to develop our work with European partners who might be interested either in participation in development of production itself or in using hydrogen produced at this site. And now to turn to Northern Transit Corridor, which I mentioned several times by now. A couple of years ago, Rosatom was appointed as infrastructure operator of Arctic region of Russian Federation. We take this role very, very seriously. We know that this project, that this region is really important not only for Rosatom or Russia, but Arctic region has tremendous resource base, and it might be effectively developed with necessary support, necessary management, effective from key players like Rosatom. Our main experience in Arctic by now was based on our icebreaker fleet, which now comprises, I think, of 6 nuclear icebreakers, last one being officially commissioned this Tuesday. And these nuclear icebreakers are a good and well-proven example of non-power application of nuclear technologies. Our first nuclear icebreaker was commissioned in 1959. So we have good basis to say that it's a good solution for Arctic, and which allows us currently to investigate different opportunities for developing this region and help our Russian national companies together with the international partners develop huge infrastructure projects in this region. And of course, it is of course part of energy applications of nuclear power, of nuclear energy, but we cannot avoid topic of closing nuclear fuel cycle because nuclear industry as it is should be responsible about what is left after we use nuclear fuel for energy production, so for research reactors. So Rosatom pays great attention to development of closed nuclear fuel cycle. We do it, we have quite extensive research and production base in Russia. It comprises of number of nuclear fuel cycle facilities, which can cover most activities related to reprocessing and storage of spent nuclear fuel. And in 2021, we have launched construction of Brest fast neutron reactor, which is a substantial element, crucial element of closed nuclear fuel cycle of the future. with increased safety and more effective usage of uranium. We are also developing a number of projects related to closed nuclear fuel cycle with our international partners who are interested in combining their solutions with our technologies to use for nuclear power to become most effective and eco-friendly. And at the end, I would like to mention our world's only and first and only floating nuclear power plant. I do it intentionally because I know that focus of my speech should be non-energy applications. And this is exactly the case because this power plant not only produces electric power, it supplies nearby city and production facilities in Pevek. It is in Chukotka region of Russian Federation, Far East. It supplies the whole city with heat. And we are currently investigating options to develop our optimized floating nuclear power units to our customers with more focus on heat production than on electrical production. Because as we found out, there is a demand also for such use of floating nuclear power plants. And another type of our small modular reactor solutions is land-based. We are going to build our reference reactor, first one in Russia. The deal, the agreement with regional authorities was signed on January 20th. So our first land-based SMR would be located in Yakutia region. It would also work with local industrial and regional customers. So we are looking forward to launch effective dialogue with all our global partners to jointly promote nuclear. Thank you for your attention. Thank you, Marcus. I'm ready to answer your questions.
Thanks, Dmitry. It's a fascinating presentation. So there's so many topics here, but I want to pick up on first of all on the topic of hydrogen production. You mentioned your facilities both in Kola Peninsula and the Far East. So starting with the one here closest to us in Kola, well, how far have you come in the plans there? How close to starting producing the production of hydrogen are you?
Thank you, Marcus, for your question. Well, currently we are drafting this, I would like to call it the concept of this class. We already have this concept. Now we are putting all the elements to this puzzle. I think that if our discussions with our industrial partners go well, we could look forward to first isotope or first hydrogen supplies in nearest 2 years.
And what kind of volumes are we looking at here? have you got a sense of what just to give us a sense of how much hydrogen are you planning to produce there?
I don't want to lie, but my understanding that it would be around maximum capacity, considering free energy capacities at coal and PP, should be around 30,000. Just a second. Yes, up to 30,000 tons.
Okay. So, and is that intended for the mainly European market, or is it intended to use locally, or just to get also a sense of, are you going to distribute that to the, for example, to the Swedish projects, or what's the plan there?
I think we are more interested to export it, but at the same time, both Rosatom and other Russian players who are currently developing hydrogen technologies, we are working on building internal demand on internal market. So we investigate opportunities to develop hydrogen transportation. There are pilot projects in development. I've heard in Moscow, in the Murmansk where coal and PP is located, and they could cover a part of initial supply which Rosatom can provide. But at the moment, the main focus of this cluster is export to Europe. We are looking forward, we are investigating whether it could be done to Sweden, to Finland, and of course to Germany.
And is that the more likely options to use pipelines then to export the hydrogen, or?
One of options is pipelines. Another options is using naval routes.
Okay, and yesterday we talked quite a bit about the potential to integrate hydrogen production through high temperature technologies integrated in the nuclear plant. Is that the sort of family of technologies you are intending to use in the Kola, or is it low temperature sort of PEM or alkaline electrolysis using the electricity in a more traditional way, for lack of a better word?
For Kola cluster, we are going to use electrolyzers because our main the main input for this project, the starting point is that we actually have operating nuclear power plant, which has around 200 megawatts of free capacity, which we need to utilize. So after our initial investigations, we, for the moment, we stopped on option to use electrolyzers on site or nearby the plant.
Okay, I'm afraid we're out of time. Dmitry Tsivilev from Rosatom, thank you so much for joining us. And
it was my pleasure.
Yeah, and all the best with your plans for the future. Thank you very much.
Thank you, Marcus. Bye.